Hey guys, so today we're doing lesson 6.5 entitled Trigonometric Ratios. I'm actually breaking this into two lessons, so it'll be this one and the next one. Now, many of you have already learned at least the main three trig ratios in Algebra 2 or Geometry or both, possibly even Algebra 1 they might touch on it. That's sine, cosine, and tangent. So the first three, and you may have learned SOHCAHTOA. I mean, it depends on what previous teachers have tried to teach you. But sine, cosine, and tangent are the main three trig ratios. Now, a ratio is just another word for a fraction. So they come from a right triangle, and you basically take one of the angles out of a right triangle, not including the right angle, but one of the other angles, usually called theta, and then you take the various sides and create fractions. So every triangle has three sides. They have names. The names are opposite, adjacent, hypotenuse, and you arrange those in fractions. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And those fractions or those ratios are given names. The first one being sine, the second one being cosine, the third one being tangent. So those are the main three trig ratios. You may or may not have learned that there are three others, and that just depends on the school you came from before you came to Tolles, how far your previous teachers got into their classwork. Sometimes they run behind and they don't cover everything. You know how that goes. So the other three are cosecant, secant, and cotangent. They're also ratios. They also involve an angle, theta, you can see there. Here, I'll highlight these in maybe just a different color. And what these are, they're basically the same as the previous three ratios. They're just flipped over, or reciprocals. So sine up here is opposite over hypotenuse. Cosecant is hypotenuse over opposite. So these two are kind of partners in the way. They're just flipped over. And then the same thing goes for cosine and secant. That's adjacent over hypotenuse, hypotenuse over adjacent. And then tangent, opposite over adjacent, adjacent over opposite. So I'm kind of going through these at least like you already know the first three. Hopefully you do, or you were supposed to have learned them. Maybe you forgot them. I don't know. I'm just trying to make it a little cleaner now with my highlighting. The other three, if you don't totally know those, it's okay. You'll be fine. You'll get through this course just fine. If you never learned any of them, then you might need to work a little harder than some of the other people in this class. Or if you've forgotten most of the information, because I am basing this off of the fact that you know at least some basics. So what we're going to do today is we are going to be exercising your knowledge and practicing your knowledge of these trig ratios. Given various triangles, can you set up the appropriate trig ratios? And some of these will have diagrams, some of these will not. Now, speaking of diagrams, the typical triangle diagram is sort of what I have drawn here. So you've got a right angle, and that box will always indicate the right angle. The hypotenuse, of course, is always across from the right angle. And then one specific angle will be indicated as being important. That's theta, as you can see here. Oops, did not mean to erase that. Meant to emphasize the arrowhead. Theta right here. The side across from theta is called the opposite. The side that touches theta is called the adjacent. But what frequently happens is you're given a triangle that's not set up like that. It's like sort of twisted and turned, and you got to figure out what side is what. And it's inevitable that students have trouble with this from time to time. So what we're looking at here is, hold on just a second. Okay, sorry. So what we're looking at here is a triangle that's sort of turned, but keep in mind the first side you want to identify probably is the hypotenuse, because it's always diagonally across from the box, the right angle. The next side generally that you identify is the opposite, because it's the one across from the theta, which makes the third side automatically the adjacent. The word adjacent means touching, so the fact that this side actually touches the theta angle right there, it makes sense that it's called the adjacent. Opposite sort of means across from. That could be confusing, I guess, for some people, because the hypotenuse is across from the box. So those are just facts you kind of need to get ironed out so that you can at least label your diagrams well. Now, the other diagram you need to be familiar with is your standard geometry diagram for a right triangle, because we do use the Pythagorean theorem a lot. So in a standard right triangle, capital C is given for the right angle, capital A and capital B are the other two angles. Little a, little b, little c are just across from capital A, capital B, capital C. This is independent of the whole adjacent, hypotenuse, opposite stuff. You generally learn this before you learn any trig, but the simple formula a squared plus b squared equals c squared, that's the Pythagorean theorem. Now, if you want to, you can adapt it to opposite squared plus adjacent squared, equals hypotenuse squared. It's a mouthful to say, it's a lot of extra writing, so probably you won't want to do that. I'm just saying you could, but usually people are happiest writing a squared plus b squared equals c squared. So we will be doing that. Now, whenever you use the Pythagorean theorem, inevitably you get to a point where you need to square root something at the end. Sometimes that's not a big deal. Like if you get, c squared equals 25 and you need to square root both sides, then fine, c equals 5. I know generally we do plus or minus, but not in geometry, not right now anyway. So we would just call that 5. But what if you're doing a problem and you get c squared equals 15 and you square root both sides? So you get c equals square root of 15. Do you go to the calculator and type that in and work out a decimal answer? You could, and if the instructions tell you to, you could. But for right now, we are going to leave everything in radical form rather than a rounded decimal value. So we're not going to use the calculator to get decimal values on square roots whenever that comes up. Okay, so I've talked a lot. Let's look at what's going to be expected of you. So find the value of the trig function indicated. Trig function, trig ratio, kind of really just the same thing. So number 2, find the cosecant of theta. All right, from up above, cosecant, one of the 6 trig ratios, is hypotenuse over adjacent. Now I'm actually paranoid that I've confused myself and forgotten, so I'm going to double check. Yep, see what I did there? Hypotenuse over opposite. Duh, dunderhead. So that's why it's good to have notes. Hypotenuse over opposite. So if we look at this triangle, what's the hypotenuse and what's the opposite? Well, the hypotenuse is across from the box. The opposite is across from theta. So in this problem, our answer is going to be 10 over whatever the opposite is. But we need to figure that out. So how do we figure that out? Well, we could call this A, B, and C. Remember, C is always the hypotenuse. So a squared plus 8 squared equals 10 squared. And then do the math here. A squared plus 64 equals 100. Subtract 64. A squared equals 36. Square root both sides. Now 36 is a square number, so A works out to equal 6. So now I know that the opposite is 6. I can plug in 6 to my answer, and I get 10/6. Although, keep in mind that fractions can reduce, so I'm going to reduce that to 5/3. So the instruction said find the cosecant of theta, and I have determined that the cosecant value of theta is 5/3, or the cosecant ratio of theta is 5/3. Let me check number 2 and see if I did it right. 5/3, and there it is. So again, this is just an exercise in setting up trig ratios. We're not really solving much. I guess we did kind of solve a missing side here using the Pythagorean theorem. But yeah, that's kind of what's going on. Now, does every problem work like this one? No, there's some variety. So sometimes I say, if you get it, stop the video and just go ahead and get to work. And you always are free to do that. I mean, it's your life, it's your school, so do what you need to. But some of these problems do change and get a little more complicated, like having radicals and stuff. So you might want to go ahead and follow along still before you get to work. That's up to you. All right. Number 4, find the cosine of theta. Cosine is adjacent over hypotenuse. And I'm not paranoid. I know it's adjacent over hypotenuse, but I'm going to just go ahead and check anyway, just sort of devil's advocate, give you an idea of what you can do when you're doing your assignment. You scroll up and down and check things as you work things out. All right, so it's adjacent over hypotenuse. Now in this triangle, the hypotenuse is right here, and over here is the opposite, and this is the adjacent. So we know our answer is going to be something over 19 square root of 2, right? Adjacent over hypotenuse. So what is the adjacent? There is kind of a trick you can do on this problem to figure it out, but it doesn't apply to every problem. So I'm going to go ahead and work this out like I did the last one. So this we'll call A, this is B. Remember, the hypotenuse is always C. So 19 squared plus B squared equals 19 radical 2 squared. You follow that okay? All right, what is 19 squared? Am I ashamed to admit I don't know? Nah, I'm not going to let that bother me. 19 squared, come on calculator. 19 squared is 361, plus B squared equals, now how do I do 19 squared to 2 squared? Well, I apply this square to both of those. So 19 squared is 361, and square root of 2 squared is 2. And what is 361 times 2? That's 722 equals B squared plus 361. I don't think I need the calculator anymore. I'll get rid of that. Whoa, what happened? There we go. Subtract 361 on both sides. I get B squared equals 361. 722 minus 361 is 361. When I square root both sides, well, we just talked about how 19 squared is 361, so the square root of 361 is 19. This side is 19. So when I said there's a shortcut on this, or a trick on this particular problem, if you see 19 and 19 radical 2, that means that this side has to also be 19. It's a isosceles triangle, if you remember that. But that's an obscure kind of a little trick, recognizing the radical 2 with the thing. But yeah, you can just do the Pythagorean theorem. Regardless, what that means is that this 19 goes here. Now in the last problem, I had to reduce the fraction. In this problem, I also have to reduce the fraction. These 19s cancel, gives me 1 over radical 2. But there's also this issue that, you know, hopefully you're never supposed to have a square root in the bottom of a fraction. I'm going to actually bring this down here so I have a little more room to work. So rationalizing the denominator, that's where you multiply by square root of 2 over square root of 2. Top times top gives you 1 times square root of 2 is square root of 2. Bottom times bottom, square root of 2 times square root of 2 is square root of 4. And what is the square root of 4? That's 2. So the answer here is square root of 2 over 2. So number 4 was a lot of work. That's actually probably the worst type of problem on the whole paper. Some of them are easier, some of them are sort of in between, like number 2. Number 4 has probably the highest quantity of work you're going to see on this whole worksheet. All right, let's look at number 6. So cotangent of theta. The definition of cotangent is adjacent over opposite. Now, man, I know that's the right answer, but I'm so paranoid of making mistakes right now. Adjacent over opposite. Yep, got it. Okay, so in this triangle, the 6 is opposite. The 8 is touching theta. That's the adjacent. The one across from here is the hypotenuse. Now, in the last two problems, I had to do the Pythagorean theorem to find the missing side. In this problem, I don't care what the hypotenuse is because it's not part of the answer. Cotangent is adjacent over opposite. That's 8 over 6. You can reduce 8 over 6. Sure, 8 over 6 reduces to 4 over 3, and that's the answer. So we went from a problem with the most amount of work you could possibly have to do to one with hardly any work at all. And that's kind of how this goes sometimes. Now I realize I forgot to check number 4, so I'll scroll down and check number 4 and number 6 at the same time. So number 4, square root of 2 over 2. Number 6, 4/3. So hopefully you see that some of these are easy, some of these are more challenging. Hopefully none of them you're going to find difficult. Secant. Now, what I can say about this one is kind of like what I said about number 4 up here. We've got 8 and 8 square root of 2. If you remember from geometry, that's a little tip off that this is an isosceles triangle, 8, 8 square root of 2. So I'm going to sort of save ourselves a bunch of the work that I did up in number 4. But I'm kind of forgetting something. What is secant? Secant is a trig ratio. It's hypotenuse over, and I'm going to go just check my notes, adjacent. Hypotenuse over adjacent. In this triangle, the hypotenuse, of course, across from the box. The adjacent is the one touching theta. So that equals 8. So hypotenuse over adjacent is 8 square root of 2 over 8, right? This over that. The 8's cancel, give me square root of 2 over 1, which is just square root of 2. And that should be the answer to number 8. And yes, it is. Now, if you're asking yourself, what if you don't understand that little trick? What if you don't remember the whole number? Well, here, I'll sort of jot it down. It was, well, let's see. Probably in geometry, you learned something called a 45-45-90 triangle. And it was like, I don't know what variable is used in a geometry book. I'm just going to go x squared root of 2. And that these two angles equal each other. It's an isosceles triangle. Isosceles means two sides are equal, and then the hypotenuse works out to be whatever that variable is times the square root of 2. So it's just a thing, if you recognize, you can save yourself from work. Save yourself some work. If you didn't understand that, what I just did, then you would call this, you'd say, okay, this is an unknown. I don't know what it is. This is A, this is B, this is C. A squared plus 8 squared equals 8 radical 2 squared. And then you just go through all the steps of solving the Pythagorean theorem, just like I did right here. 19 was kind of a pain in the butt number. I had to use a calculator. 8 is a much easier number, so this wouldn't be quite so bad. But the point is, once you do all this work, you will get 8, and that's how we got that answer. Okay, number 10. So sine of theta is opposite over hypotenuse. The opposite is here. The hypotenuse is here. There's another little trick or shortcut from geometry that can help you out on this. I don't want to overwhelm you with a bunch of extra details and facts, so I'm just going to throw a word out there, a phrase. If that helps, great. If not, don't worry about it. So if you remember anything about what was called the 3-4-5 triangle, that could help you here. It could eliminate a bunch of work. So if you know, if I'm talking some sort of secret code and you understand what 3-4-5 means, that's what this is. For the rest of us normal people who don't live in math all the time, yeah, I'm just going to treat this like every other problem. So opposite over hypotenuse. The hypotenuse is 10. The opposite is clearly an unknown. So if I call this A, this is B, this is C, then A squared plus B squared equals C squared. 6 squared plus B squared equals 10 squared. 36 plus B squared equals 100. Subtract 36. 100 minus 36 is 64. Square root both sides. B equals 8. So this side is 8, which means an 8 goes there. 8/10 reduces by 2 down to 4/5. 4/5 is the trig ratio, the sine ratio. Let me check and make sure. There it is. All right, looks like the next one is going to be a challenge. I peeked at the answer a little bit. Yeah. Okay, so number 12, tangent. We're asked to find the tangent value of theta. Tangent is opposite over adjacent. Now, what's opposite? Is this side because it's opposite from the box? No, that's the hypotenuse. Opposite from theta is 23. Adjacent is right here, 4 radical 6. So the good news is we don't need to use the Pythagorean theorem to solve for the hypotenuse. I mean, if you're bored, you could, but you don't have to. It doesn't matter. Opposite over adjacent is simply 23 over 4 radical 6. You look at it like, oh, all I got to do is plug in this number here, not too bad. No, it's not too bad, but we do have that situation where we have a radical in the denominator, which you're not supposed to have. So I need to rationalize this by multiplying by square root of 6 over square root of 6. Top times top, that's 23 times the square root of 6 is just 23 square root of 6. Bottom times bottom, 4 times square root of, 6 times 6 is 36. What is the square root of 36? Are you the type to talk to your iPad when I ask a question like that? What is the square root of 36? And then I pause and you say, the answer, 6. Or are you the type to just shake your head and say, Haskell is losing his mind? I don't know. Anyway, the bottom, 4 times 6, 24. And that should be the answer. 23 radical 6 over 24. Let's check. And there it is. All right, so the next few problems are really just the same, but you need to draw your own diagram. So I'm going to draw sort of the typical right triangle with A, B, C as the points. A, B, C. Make sure C is always the right angle. Oops, didn't mean to do that. Just trying to get a nice straight line for my box. And then little a is across from big A, little b is across from big B, little c is across from big C. So find tangent A. So now we're not using theta, we're actually using A, so that's our angle. If little a equals 15 and little c equals 17. Right, so we're being asked to find tangent. Tangent of any given angle is opposite over adjacent. In this diagram, we're looking opposite of A. The adjacent would therefore be B, and C is, of course, the hypotenuse. So opposite over adjacent is going to be 15 over whatever that is. So let's calculate the adjacent. 15 squared plus b squared equals 17 squared, right? I'm doing a squared plus b squared equals c squared. What is 15 squared? I know that's 225. What's 17 squared? Oh, good grief, I don't know. 17 squared, 289. Now I need to subtract 225 on both sides. B squared equals 289 minus 225 is 64. Well, that's convenient. Square root both sides. We get 8. So 15 over 8. That's the answer. You don't even have to reduce that. Let's check number 14 to make sure I didn't mess up. 15 over 8 it is. All right, next one. Again, we need the ABC triangle diagram. So give me a second here. So capital A, capital B, capital C, little a, little b, little c. Find the cosecant of capital A. All right, what is cosecant? It's hypotenuse over, I forget. Cosecant over opposite. Okay, in this problem, the hypotenuse here equals 17. So I know my 17 is going to be right there. The B right here is 8. Now we're doing the cosecant of angle A, that's right here. So we want the opposite. So again, we need to do the Pythagorean theorem to solve for A. However, it's going to be simple. And why do I say that? Because it's essentially the same triangle as the last problem. It's oriented exactly the same, right? So this was 15, and this worked out to equal 8. And then, of course, that hypotenuse was 17. We got 17, 8. So, of course, this is going to be 15. and that's going to be the answer. Now let's say we didn't just know that, you know, it's like maybe just a coincidence that 14 and 16 are the same. Maybe you're not going to have that luxury on 13 and 15. So yes, I would do the Pythagorean theorem. What was 17 squared? Was that 289 minus 64 on both sides? That's 225. Square root both sides. The square root of 225 is 15. So yes, clearly you can derive the answer by using the Pythagorean theorem. But anyway, hypotenuse over opposite. Hypotenuse is 17. Opposite is 15. Put 17 over 15. It does not reduce. Therefore, we would say that's it. All right, so that's the whole worksheet. Please do the odds just as I did the evens. Like I said, it's just practice to make sure that you can set up trig ratios and use the Pythagorean theorem. If you have issues or questions, please contact me. I'll do my best to help you out. Other than that, have a great day.